Hello coders, welcome to Level Up with Coding. Today I will be discussing the problem 950 reveal cards in increasing order, and first understand what the problem is. Okay, the problem is basically that you have a given an array and you have to do the operation. And what is the operation? Let's assume the array is 5321. What I what I can do from this operation, the operation number 1 state that you can remove the first element and make that the element is reveal. That means you have to just remove the first element and make sure that this is reveal. Okay, and then if the array is not empty till now, then we have to remove the next element and push in the array end. That means after performing operation 1, the array becomes 3 to 1, but as the array is not empty, so we have to remove the first element and push in the array end. That means after applying the operation 2, the array becomes 2 1 3, and operation 3 states that if there is an element, so we have to perform operation 1 and 2 continuously. Okay, and this is the problem. But what we have to do, we have to make the array in such a way such that from the array, after revealing the all the elements, that means using this operation, the revealing sequence what we will get from that array, the sequence will be increasing. The sequence would be increasing. That means for that case the revealing sequence will be, for first case we getting 5, and if we apply again the revealing operations, that means for the next time the first element will be removed and this will be add in my revealing sequence. As the array is not empty, so we have to remove the second elements also and push in the array end. Okay, so again we see that the array is not empty, so we have to make operation again. So we have to remove the first element, so we make the in my part of sequence, and again we see that my array is not empty, so we have to remove the last second element also and push in array end. Okay, so we see that this is array is not empty till now, so we have to make another operation again. So if we remove the first element, this will be my part of my in sequence, reveal sequence, so that after that the array is now empty, so we stop. And what is the reveal sequence? 5 to 3 1, but this is not an increasing sequence. Increasing sequence means previous element should be less than the next element, always in this way. Okay, so we have to find from the array such a reorder of the element, so that after performing the reveal operation in the reorder array which we form from the given array, so that the reveal sequence become increasing. Okay, if we consider the example 5321, so we have to find and reorder of that array, so that after applying operation in the array, we can easily get the reveal sequence as increasing. Okay, so we have to find the array, and from after finding the array, we have to apply the operation, and after applying the operation, the order should be in increasing. So we have to find such array. So we can say, what is the increasing reveal order sequence for that array? That means if we say that my sequence is this, we can try to find the array order from the sequence itself. That means reveal sequence itself. So I have given the array is 5321. So what is the reveal order sequence? That means how the increasing sequence looks like. The increasing sequence should be 1 2 3 5, but we have to form the array such a way so that after applying the operation, we can find the sequence is 1 2 3 5. We have to find such reorder of that array. I think the problem is now clear. Okay, So what is the extreme brute force approach for this? Okay, the extreme brute force approach for this is that we can find all permutation of the array. Permutation of that array means all possible combination of reorder. Okay, so if we uh, find all possible reorder of that array, and from that reorder if we try to find what is the reveal order sequence, from every permutation we can find in reveal order sequence. And how we can find reveal order sequence? After applying this operation, that remove the first element, and if there is an element, second element is also remove, and the second element and push the second element is the array length, and continue this process until the array becomes empty. Okay, so every permutation we apply the operation and we get an sequence every permutation. And if we see that my sequence is increasing order, that means the permutation is my answer. Makes sense, right? If we see that my sequence is increasing, that means the sequence is increasing, so I can easily set the permutation we, from that permutation we get the sequence, the permutation is my valid answer, right? So the brute force approach is try to generate all possible permutation of that array, and for every permutation find what is the reveal sequence. And if we see that reveal sequence is increasing, that means the permutation is valid. That means for 5321, for 5321, what is the increasing reveal sequence? The increasing reveal sequence is 1 2 3 4, we know, but we have to find such reorder of an array so that after applying the operation the sequence will be get, it will be increasing. That means the sequence is 1 2 3 4. Okay, so if we say that my one of my permutation is 1 3 2 5, I can say 1 3 2 5 is my one of permutation, because all the element in my the original array is present. Okay, so this is an permutation. So what will be the reveal sequence for this? The reveal sequence is, first you have to remove the first element, so and add this in my reveal sequence. So one the first element of my reveal sequence, then we have to remove. Again, if we see the next element is there, so we have to remove them and add in the array last. That means the array becomes 2 5 3 now. Now the array is not empty, so we have to make again the reveal, again the operation. That means 2 will be removed and 2 will be add in my reveal sequence. And as the next element is not empty, so we have to remove them and add in the array length, array last. So this will be 3 5. Now my array is not empty, so again we have to perform the operation. So we have to remove the first element, add in my sequence, and the next element is not empty, so we have to remove them and add in the array last. So the array becomes now 5. Okay, so the array is not empty right now, so what I have to do? I have to again the first element. What is the first element? This is 5 itself, so we have to remove them and add in my reveal sequence. And we see that there is no element, that means array is now empty, so we have to stop them. And what is the sequence? 1 2 3 5, and this is an increasing sequence, so we can say 1 3 2 5 is my answer for the given array 5 3 2 1. I think the problem approach is clear, and for applying brute force it will take a lot of time, because for generating all permutation it will take n into n factorial, and for every permutation of my array we have to generate the reveal sequence. So the reveal sequence will also take n time, because we have to at least iterate through all the element. So this is so high time, this is n square into n factorial. Okay, so the solution is not good. Okay, so we have to think about better approach. Okay, I think the problem statement is clear till now. Okay, and let's move to the example and try to understand what will be the optimal approach for that problem. Okay, and let's see what is the first examples. In the first example, the array elements are 17 13 11 2 3 5 7, but the output is 2 13 3 11 5 17 7. This is the answer, and we have to find this answer from that reorder. But how we find? But we know for that array what is the reveal order sequence will be. Valid reveal order sequence will be, the valid reveal order sequence will be increasing array, because we have to find such and reorder so that after applying operation in the reorder array we can find an increasing reveal sequence. So we know that the sequence will be increasing. Increasing means for that array what is the increasing sequence, we can easily say that the increasing sequence is 2 3 5 7 11 13 17. So we know the sequence, increasing sequence we know, but we have to find the what is the reorder to get the increasing sequence, right? So we have to find the reorder, because we always know the what is the increasing sequence, because if we sort the array we can easily find what is the increasing sequence, because the increasing sequence will be always sorted, because the previous element always lesser than the next element. Okay, so we know the what is the given array and we know the what is the increasing sequence will be, but we have to find what is the reorder of the array, so that the after applying in the reorder array so that we can find the reveal order sequence is increasing. Okay, so you have to find the reorder. Okay, till now I think this makes sense, right? Okay, now take an small observation. Okay, like if I have only one element, like I have only one element 5, I say that my increasing sequence also 5, because if I given an array, so increasing sequence also 5. So I know the increasing sequence, but what is the order for that element? I mean, I have given an array and I know what is the increasing sequence, so I have to find what is the reorder of array. So I can easily say the reorder of array is also 5, because if we apply operation on 5 we can easily get the reveal sequence also 5. Okay, so if I say that my current array is 5 2, so what is the reveal sequence will be? The reveal sequence will be 2 5, because the reveal sequence always be increasing, so this is the reveal sequence will be. But what will be the reorder? What will be the reorder? For that we can get the reveal sequence as increasing, so we have to find that reorder. So we can say that the reorder also 2 and 5. Why you can say 2 and 5? Because if we apply operation on 2 we can first remove 2 and we can easily get 2, and after that there is next element, so we remove them and push in the array end, so this will be 5, and for 5 we know the reveal sequence is 5. The reveal sequence is 5, because for a single element the reveal sequence is always 5, and for 5 we know the reveal sequence is also 5. Okay, okay, but what if we can say that the my array is like 5 1 2, what is the reveal sequence? The reveal sequence is 1 2 5, because we know the reveal sequence always increasing order, so we know this is my reveal sequence. Okay, but one case, for 2 5, if we compare with the previous example, for 2 5 we know what is the reveal sequence will be. The reveal sequence is 2 5. Okay, for 2 5 the reveal sequence is also 2 5. For 2 5 the reveal sequence is also 2 5, but we are just adding 1 in my reveal sequence. So can I say that my reveal my order first element also 1? Why we can say that my order first element also 1? Because in my reorder array we just to get the reveal sequence we have to first remove the first element, then we have to perform another operation, but I can sure that the first element will be my sequence first element. Okay, but if we say that 1 to 5 is my order to getting the sequence 1 to 5, this is not the valid. Why not the valid? Because if we remove the first element we can easily get 1. Okay, no problem, but when we remove 2 and push back in the array end, my array becomes 5 2. But we have to find what is the but we find for 1 we have find, but we have to find for 2 5 what is the order. But for 2 5 we know order will be 2 5 also, but we getting 5 2. but this is not valid. Okay, so what we can do, we can observe a thing like in previous, if there is two element that my increasing sequence is 2 5, and we get that my order of array will be 2 5. Okay, I I I just eliminate the things what is the original array. Okay, because the original array can be 5 2 or can be 2 5. Okay, so first just focus on the what is the increasing order. The increasing order will be 2 5 for 5 2 also increasing order 2 5, and 2 5 also increasing order 2 5. And we know for 2 5 the order of the array should be 2 5 to getting the increasing sequence. Okay, but if we just add an element previous, and what is the increasing what is the my order of array, we know if we adding one element in first, so we can surely set the first element of my order also that element, because we have to remove the first element as per rules, and after removing the first element we get the first element of the sequence. So the first element of the order is should be this. But one case, and after removing the first element, what we have to do, we have to just remove the second element and push back in my last element. Okay, this is the thing. But we know for 2 5 it should for 2 5 the sequence should be 2 5, we know. But if we adding an element, so we have to take the second element and push back in the last. That means for second element, like if we assume that my sequence is 0 to 5, and for 0 we easily get that it is the top element, and the top element also 0, so we remove the first top element and we can see out that this is the my first element of my increasing sequence, and then we remove the second element and push back in my array end. So this is 5 2. Okay, but this is not valid, because we have to find the sequence for 2 5, and we are getting that 5 2, but we have already calculated that for 2 5 it must be the sequence must be 2 5. Okay, that means the order must be 2 5. So what I can do, can I say that my current sequence is 0 5 2? How I can say? Because we just have to take care of the first element, because if we remove the first element, what is the first element? This is 0, because this will be the part of my sequence, and the second will be removed and this will be add in the array last. So now this is become 2 5, and we have calculated that for 2 5 this is also 2 5. So I can say that 0 5 2 is my valid sequence. So what I am doing, I just removing the previous last element. That means we have to order the array for 0 to 5. Okay, and I know for 2 5 the order is 2 5. So to getting 0 to 5 sequence, to getting the sequence for 0 to 5, that means for the increasing sequence 0 to 5, what will be the reorder? We know for 2 5 the reorder is 2 5. So what I can do, I just remove the last element and push in the first. That means this become 5 2, and simply add what is my current element we have just want to add. This is 0, so that after performing first operation we can go back the previous operation, right? Because when you remove the first element and take the second element and push back in the last, so we can easily find this is 2 5, and we have to remove 0 and 5, so from 2 5 we can easily get. So we can say that what is the next order? This is the previous order, last element will be the first and current element will be again first. In that way we can find, like let's take for 0 to 5, we know the sequence is 0 5 2, but if we want to find that let's assume that there is -1, but -n for that case is not valid. I am taking for just an example, because -1 0 to 5 it my valid sequence, right? -1 0 to 5 it my valid sequence. Okay, and I know for 0 to 5 the valid sequence is 0 5 2. So what will be the sequence for -1 0 5 2 0 to 5? So what I am doing, I just removing the last element. What is the last element? 2. I removing and push back in the first. So my sequence is like now 205. And again I am adding the current element, that means minus 1. So this will be the sequence for minus 1 0 to 5. I think the approach is now cleared. We just build my reorder array from one element to for n element. That means for the given example, that is given that the elements are 17 13 11 2 3 5 7, and I have to find the reorder which gives me the sequence. Reveal sequence is 2 3 2 3 5 7 11 13 17, right? So what I can do, I just always try to build from the last. If there is only one element, the sequence will be only 17. If there is two element, the sequence only that's two element like 13 and 17. But what is the order for 11 13 17? 11 13 17, the order will be, I have to just remove the last element, push in the first element, and just add the current element 11 17 13. In that way we can find the sequence. Okay, I think the approach is now clear, and just write down the first example and let's move to the code. That's it. So we have given the array and we know the reveal sequence will be 2 3 5 7 11 13. So we have to build what is the reorder of the array. So we build from the last. So we know for 17, what is the reveal order, what is the order of array, because this is an one element, so the order will be only 17. But what is the order for 13 17? This is also 13 17, because two element for that exact two element, that means not exact two element. If this is sorted, so if we remove the first element we getting 13, and again we have to just remove the second element and push back this remains 17, and we can get easily 17 13. But when we try to find what is the order for 11 13 17 sequence, so we just see the rules. What is the rules? That we just remove the last element and push back in the second in the first element and push the first element in my current. So 11 17 13 gives me the sequence 11 13 17, and what I have to do, I just have to find the sequence for 7 11 13 17, because for 11 13 17 we know the sequence is 11 17 13. But for 7 11 13 17, what I have to do, we just have to remove the last element and add in the first, and this become 13 11 17, and add the current element. This is 7 13 11. In that way, if we do the dry run, we can easily find the sequence. So just move to the code. What I can do, so we just first one element we just add in my Deque. We are using Deque because we have to remove from the last and add in first. So Deque will make easier for that. So we will be using an Deque. So what I am doing in each step, first we have to sort the array. Why we are sorting the array? Because we have to first get the increasing order of the reveal sequence, and then from the reveal sequence we will find what will be the order, what will be the reorder of my reorder of my original array. Okay, so for first element, that means for the last element we know the reorder itself the last element, and for the next element itself we again continue the process. And what is the process? We just remove the last element and push in the first and push the current element in the first, what I am trying to reorder. That means for 1 2, if I try to add x, so we just, if I see that for 1 2 the order is 1 2, so my for x 1 2 the order will be, we just remove x about 2 from the last and push in first, so this will become 2 1, and just add x in first. So x 2 1 will be the order for the increasing sequence x12. Okay, so this way we can find. And what is the time complexity for this? The time complexity is for this n log n, because we are sorting the array and it will take n log n time, and we just iterating through all the elements, so this will be plus n, and this is equivalent to n log n. And what will be the page complexity? As I am using an Deque to remove the last element and push in first in that way, so the space complexity will be order of n. Okay, so let's move to the code editor. So what I have to do, I have to do first sort the array, then I am finding what is the length of my array, and then we are declaring an deque. We am using deque. Why? Because we have to remove from the last and push in the first. Okay, that's why we are using an deque. And what I have to do, as I mentioned, that for one element, that means after sorting the element, that means we have to first what is the last element in my queue. That means what is the last element in my array. So the last element is deque of n minus 1, so just we have to add deque of n minus 1 in my queue first, because the for one element we know this is the order. Okay, and after that, that means we work on last element, and we have to work from the last to first, that means from n minus 2 to 0. Okay, and what I have to do, we have to always remove the last element. That means we have to always remove the last element of the queue, deque, and we have to add the last element in my deque first. Okay, that means we have to add first the last element, and we have to also add what is my current element. Okay, the current element is deque of I. Okay, and at the last the queue gives me the result. That means if we declare an array result which will be n length, so my queue first element, my deque first element will be my result of 0 element, my deque second element will be the result of second element. So we'll iterating from 0 to less than n, and we always say that my current element is my queue remove first. We always remove from first, and the first element will be my result added first element. Okay, and this will be my current sequence. So we just remove, we just return the result. Okay, and let's submit the solution. Yeah, it's accepted, and let's submit it. Yeah, it beats 86%. In case the video is helpful for you, make sure you subscribe our channel and like the video, and make sure you share with your friends. Thank you.